So in this class, we will solve a problem of ordinary differential equation by Taylor series method. So numerical solution of ODE, ordinary differential equations, using these three methods. We have to study Taylor series, Euler's method, and Range-Gupta method, RKB Range-Gupta. So the standard ordinary differential equation will be like this: dy by dx is equal to function of xy given y of x naught is equal to y naught. That means here x naught is the initial value of x. It can be 0 or 1 or any other value. The value of y at x is equal to x naught is y naught. That will be defined. So such problems are called as initial value problems, IVP, initial value problem, because the value of y is given at an initial value of x, that is x naught. So first let us take up Taylor series method. This is the Taylor series. So we have to remember this Taylor series. So Taylor series states like this: a function y of x, a function y of x is equal to y naught, that is the initial value of y at x is equal to x naught, plus x minus x naught into y dash naught. So y dash naught is the value of dy by dx. So the y dash is dy by dx at x is equal to x naught. This 0 stands for x is equal to x naught. Plus x minus x naught whole square by 2 factorial. You know that 2 factorial is 2 into 1 into y double dash naught. Y double dash naught is d square y by dx square at x is equal to x naught. Plus x minus x naught whole cube by 3 factorial. 3 factorial is 3 into 2 into 1 into y third derivative, that is y triple dash, that is y triple dash is d cubed y by dx cube at x is equal to x naught plus etc. So like this the terms goes on. So this is called as the Taylor series. Now we will take up a problem of solving ordinary differential equation using Taylor series. The question is like this: find the value of y at x is equal to 0.1 and at x is equal to 0.2 to 5 decimal places for the equation dy by dx is equal to x square y minus 1 given y of y naught is equal to y at x is equal to 0 is equal to 1. That means the meaning of this is x is equal to x naught, that is 0. X naught is 0 here. The value of y naught is equal to 1. That is the meaning of this. So this is a initial value problem. If the values of y are given at some other values of x, then it is called as boundary value problem. Now we will discuss only initial value problem. Now we have to find out this y by using Taylor series. So for that we have to get the values of the derivatives at the initial values of x. So he has given at x is equal to x naught, that at x is equal to 0, the value of y, that is y naught is 1. Now the given equation here is y dash. So y dash is dy by dx is equal to x square y minus 1. Now and also he has given the value of x naught as 0 and the value of y naught as 1. Now we will differentiate this once again. We will get second derivative. So derivative of y dash is y double dash. Derivative of dy by dx is d square by dx square. If you differentiate this second time, so we have to use product rule here. Product rule states that derivative of, I will write the product rule here. If you want the derivative of product of two functions u and v, where both u and v are functions of x, it is given by first function into derivative of second function plus second function into derivative of first function. So all this we should be knowing by differential calculus in your lower classes. You have studied this. So this is your product rule. This is called as product rule. Using this product rule, you can find out the second derivative here. So because x square is u now, y is v now. So first function is x square into derivative of second function is dy plus second function is y, derivative of x square is 2x. So this is the second derivative. Of course, minus derivative of 1 is 0. 1 is a constant, its derivative will be 0. Now this is the thing, that means it is y double dash is equal to x square into y dash, this can be written as y dash, plus 2xy. So this is the second derivative. Now let us go on finding the values of the derivatives at x naught is equal to 1, because we need these values. I need the value of y dash naught, I need the value of y double dash naught, I need the value of y triple dash naught. Now from this, the first one is this. So I will take y dash naught. Y dash naught, this is y dash. Y dash naught means I have to put the initial value of x here. So x is x naught there. X naught is 0, so x becomes 0. So 0 square into y value, initial value. When x is equal to 0, y is equal to 1. So this will be into 1 minus 1. That means it is minus 1. So the value of y dash naught is minus 1. Similarly, the value of y double dash naught, I need that also to substitute here. So this value will be y double dash naught is equal to. So now I have to put the value of x here. That means the meaning of this is at x is equal to 0. At x is equal to 0, I need this value. So here x square means it is 0 square into y dash naught. So this becomes y dash naught because I have to substitute the value of y dash at x is equal to 0 plus 2 times x is once again 0, y at x is equal to x naught, that is at x is equal to 0 is 1. We have given that. Now this value becomes 0. Y double dash naught becomes 0. So I need these values. So this minus 1 value and this value, because I have to substitute this in this Taylor series. So this is over, this is over. Now let us find out this value. Y triple dash. So first derivative is over, second derivative is over. Once again you differentiate the second derivative with respect to x, you will get third derivative. Now I have to differentiate this. Now to differentiate this, I have to use once again product rule. First function here x square, second function y dash. Here first function x, second function y. So first function x square into derivative of second function y dash is y double dash plus second function is y dash into derivative of x square is 2x. So please note that this is the derivative of x square into y dash plus 2 is a constant into derivative of x into y will be, first function is x, derivative of y will be y dash plus second function is y, derivative of x is 1. So this is what is the thing. Now if you rearrange the terms, so this is x square y double dash plus 2x y dash plus 2x y dash is 4x y dash plus 2 into 1. This is what you will get. Now I need the value of this y triple dash at x is equal to 0. So let us find out y triple dash at x is equal to 0. That is this value. So that becomes now, you have to put the value of x as 0. So this is nothing but, that means x naught. This is x naught square into the value of y double dash at x is equal to 0 plus 4 into x naught into the value of y dash at x is equal to 0 plus 2 into y naught. So like this we can write. Now this value, go on substituting, this value is 0. X naught is 0 here, given problem. So this becomes 0 into anything will be 0. Actually y double dash 0 is 0 only. So 0 into 0 plus 4 into this also becomes 0. X naught is 0. Y dash naught is minus 1 plus 2 times y naught is the given value of y at x is equal to 0, that is 1. Now if you simplify this, this is 0, this is 0, you get 2. So this is y triple dash naught is 2. Next let us find out one more term. So that is, because we have lost the value of y to 5 decimal places, let us have one more term. So more number of terms if you take, you are going to get more accurate value of y. So fourth derivative, I will write like this, y4 like this. I have to differentiate y triple dash with respect to x now. So once again here first function is x square, into second function derivative of y double dash is y triple dash, plus second function is y double dash, into derivative of x square is 2x. See, so this is the derivative of x square y double dash, plus 4 is a constant. Now I have to write the derivative of x into y dash. So first function is x, derivative of y dash is y double dash, plus second function is y dash, derivative of x is 1, plus 2 is a constant, derivative of y is y dash. See, this is how we have to do. Now let us rearrange the terms. This is x square y triple dash plus 2x y double dash plus 4x y double dash will be 6x y double dash plus 4y dash plus 2y dash is 6y dash. Now this is the fourth derivative. Now I want the value of this fourth derivative at x is equal to 0. Of course that is the next term. I have not written here, but that becomes the next term here. So you just go and substitute the value of these things at x is equal to 0. So here once again x is nothing but x naught into y triple dash 0 plus 6 into x naught into y double dash 0 plus 6 into y naught 0. Now go and substitute these values. X naught is 0, so 0, this must become, first term becomes 0. Plus second term also becomes 0 because x naught is there. Anything multiplied by 0 is 0. Plus only third term 6 into y dash 0 is minus 1. 6 into minus 1. So therefore the value will be minus 6. Okay, I can stop at this stage because I have taken 4 terms. You can take any number of terms, but you can stop at the fourth term. Now let us write the Taylor series now. So all these values are we have found out now. Now let us write the Taylor series up to 4 terms, up to fourth derivative. You can say Taylor series now states that it is y of x is equal to y naught plus x minus x naught. Easy to remember, x minus x naught into y dash. First derivative will come at x is equal to 0 plus. Now second term will be x minus x naught whole square by 2 factorial into y double dash 0 plus third term x minus x naught whole cube divided by 3 factorial into y triple dash 0 plus, since I have written fourth derivative here, one more term I will take x minus x naught to the power 4 by 4 factorial into y 4 0. Right? I'll stop at this stage. So this is what I have neglected the further terms. So higher derivative terms. Now let us go on substitute the values now. Now I need the value of y at x is equal to 0.1. So that means first I will take up at x is equal to 0.1 means I have to put x is equal to 0.1 here. So y of 0.1. Y of 0.1. Now what is y naught? Y naught is the initial value of y, that is 1 plus x is now 0.1. Please note that wherever x is there you put 0.1, wherever x naught is there you put 0. So plus 0.1 minus 0 into y dash of 0, we have got the value as minus 1. So this becomes minus 1 plus x is once again 0.1 minus x naught is 0 whole square divided by 2 factorial is 2 into 1, that is 2 itself, into y double dash 0. Y double dash 0 we have got 0. Then plus x is 0.1 minus x naught is 0 whole cube divided by 3 factorial is 3 into 2 into 1, 6 into y triple dash 0. Y triple dash 0 we have found out here, which is 2 plus x once again 0.1 minus 0 to the power 4 divided by 4 factorial. 4 into 3 into 2 into 1, 24 into y fourth derivative of 0. Oh, of course, it is minus 6. So minus 6. So this is how we have to substitute. Now let us simplify this. You are going to get the value of y at x is equal to 0.1. So 1 plus, so this becomes 0.1 into minus 1. So 1 minus 0.1. Let us simplify this. Plus here of course this becomes 0, third term, plus here it is 0.1 cube into 2 by 6. So we have to use calculator now. So this is 0.1 cube, 0.1 cube. See, 0.1 cube is 0.001 into 2 by 6 means divided by 3. So the value now here is, so 3.333 into 10 power minus 4. That is this value. Then plus last value is 0.1 to the power 4 means it is 0.0001 multiplied by minus 6 by 4 means, so it becomes, it becomes minus, divided by 4, it becomes divided by 4. So the value is 2.5 into 10 power minus 5. 10 power minus 5. Now if you simplify this, 1 minus 0.1 is 0.9. 0.9 plus this I can write in decimal form 0.00333. 0.30333 plus minus this, if you write in decimal form 0.00004025, which is same as 2.5 into 10 power minus 5. Now this is the answer now. So let us see what is the value. 0.9 plus 0.000333 minus 0.000025, which is 0.900308. 0.900308. We can check the answer. Next, similarly, we can find out the value of y at x is equal to 0.2. So we are using the same the same data series we are using. Only thing is the value of x is different here. Now let us find out